think we're good. Yes.
Thank you for having me here tonight, and I'm glad you're all interested in the Universe Sampler program. This program was created in the mid 1990s, and at that time there was no observing program aimed at the beginner like there are today. There's several. Most people back then started observing with the Messier program, and then when they finished that, they jumped right into the Herschel 400. Now that's a pretty big jump. So there really was a need for something to bridge that gap, and the Universe Sampler is that program. The booklet contains lessons that cover some of the things that the beginner needs to learn in order to be able to find their way around the night sky. So we'll talk about a few of those things and talk a little bit about some of the objects that you'll be looking at. The Universe Sampler is a league sponsored program. Excuse me. It's it is specifically designed as a teaching aid for the beginner. It teaches some of the basics that the beginner needs to learn. I like to think of it as a journey through the universe, sort of a guided tour of the night sky. You'll visit a variety of objects. Some are bright and beautiful, and some are not so bright and not so beautiful. However, they're all interesting in their own way. You begin this journey using only your eyes. Halfway through the trip, you have a choice, your eyes only or a telescope. The program offers two different deep sky lists. One is for naked eye only, and the other one for telescope or binoculars. You learn about basic sky movement, how to find north in the sky. You'll learn about angular measures of distance, like altitude and azimuth. You learn about right ascension and declination, RA and DEC for short. You learn to star hop, and you learn about eyepiece field orientation. And you learn how to log your observations. As with all of the league programs, there are rules to follow. You must be a member of the league. Use of setting circles, computer driven telescopes, or any other electronic device, such as a Pi Finder or a Nexus Pro, that is used to locate objects is not allowed. That would defeat the purpose of the program. You must learn to star hop and use that method. You must complete list one in either list two or list three. If you do both lists, you get two certificates. However, they only count as one program for any award, such as the Master Observer or some of the others. And you have to keep a log of your observations. So let's start with star hopping, since that's what you're going to have to learn how to do. It means exactly what it says. You hop from one field to the next between a bright naked eye star and your target object. You start with a naked eye star, you find it in the sky, and you find it on your star charts. And you look for little patterns of stars like these between this bright star and your target object. You can locate them on your chart, and then you find them in the eyepiece, and you move field by field until you get to the target object. It seems very difficult at first, but it gets a lot easier once your skill increases a little bit. Now, different programs require different things to be recorded. For the universe sampler, for each observation you make, your record should contain the name of the object, the date and time and the location of the observation, the condition of the sky, which we call seeing and transparency, the size of the instrument that you use and the magnification that you use, or naked eye if you choose to go that route. And then your description of the object. Seeing, in this case, has nothing to do with your eyes. It refers to the stability of the atmosphere. It's rated between 1 and a 10, with 1 being worse and 10 being best. In a sky rated 1, the stars twinkle violently. The planets look like they're in pools of water. A 10 rated sky is perfect seeing. The images are sharp and steady. 10 rated sky is very rare. I've seen it maybe 3 times in 40 plus years that I've been observing. It usually happens when it's freezing cold outside and all the moisture in the sky condenses and falls out of the sky. And when it gets that cold, I'm usually in my bed. Transparency refers to the clarity of the sky, and it's rated between 1 and 6. It corresponds to the dimmest star that you can see with the naked eye. Most people can't see stars dimmer than 6th magnitude with their unaided eye. But if you have keen eyesight and you can see 6.5 or 7th magnitude stars, you should rate the transparency accordingly. Since you need to record the magnification that you're using for each of your observations, a helpful hint for always knowing that is by putting that information right on your telescope. Here I have a list of all my eyepieces, and here is the magnification with this telescope, and if I use a Barlow. So I've got it just instantly right here. And also, the brightest stars on your star charts are labeled with the Greek alphabet. And sometimes I forget what the Greek symbols are for a certain letter, especially those that I don't use very often. So I keep the Greek alphabet also on my telescope. Now let's talk about object descriptions. In the list of requirements that I brought up before, did you notice that it said your description? So your description is not just saying that it's a galaxy or a star cluster. That's really not a description at all. It's not the description copied right out of the book. It's not what someone else says it looks like. You need to write down what you see in the eyepiece. So let's use a galaxy. And here are some questions that you can ask yourself when you're looking at a galaxy. First of all, did you see it in your finder? If you did, note that on your log. Is it large or small? Is it bright or is it dim? What's the overall shape? Is it round? Is it oblong? Is it just a thin streak? Do you see any detail on the surface? Or is the overall brightness the same across the galaxy? Do you see mottling or bright spots on the galaxy? If you do, note those. Is there a central bulge or a dark lane? Do you see spiral arms? Are there any field stars near or on the face of the galaxy? The point I'm trying to make is that someone reading your description should be able to visualize in their mind what you saw in the telescope. You can use anything that you want to log your observations. Plain paper, spiral notebook, whatever. I suggest using printed log sheets sort of like this that has space for all the information that's required right on the sheet. And if you're into sketching, you've got a place to do the sketching and a place for your description. There's a couple of these in the back of the book, and you can copy those if you'd like, or you can make your own. I use uh, custom made ones for each program that I do, and it's easy to make them up in Word. I'd suggest that you organize your logs. Uh, Use a separate notebook or whatever you're keeping track of them in for each of the programs that you observe. Once you get started, you'll find that the league has many, many programs, and you might want to observe objects from more than one program. And if you put everything in one binder, let's say, it's very hard to separate them out when you get ready to turn them in. So keep them separated. Whoops. Okay, I'd also encourage you to draw your objects. You don't have to. The only drawing you have to do is a rough uh, drawing of the constellations when you do your 15 bright stars. But you don't need to be an artist to be able to sketch these objects. Drawing is one of the best ways to train your eye to see detail. In order to draw an object, you have to really look at it. You can't just give it a cursory glance and go draw it. It doesn't work that way. You have to study it. With a little practice, you'll find that it's really not that hard to do. And you don't need much equipment, just a simple clipboard, sharp pencils, an ebony pencil and smudge stick for its extended objects like galaxies and nebula, and a good eraser. One thing that I really want to stress is that observing should be fun. There will be times when you find you're not having fun. You can't find the object, you're getting frustrated, and you just want to quit. When this happens, and it will happen, take a break, walk away from the telescope, go have a snack, or go talk to someone for a few minutes. If this object is just plain too hard to find, just leave it for a while. Build up your observing skill a little bit before you try it again. It'll still be there when you're ready for it. And remember, you can always ask for help. Most people are more than willing to help. You are not alone in this endeavor, and you should not isolate yourself from other observers. You will be surprised at how much you do learn by observing with other people. Now, let's begin our journey. Remember, you'll be using only your eyes for the first part of this program. Your first encounter will be 15 of the brightest stars in the sky. You'll learn their proper names and learn in which constellation they're found. These stars will become your guideposts for finding all those little faint fuzzies that are in the sky. Here's some of the brightest stars. And when you observe stars, always look for color. You'll very seldom see color in anything else that you observe. Like Betelgeuse and Antares are definitely reddish. Canopus and Capella are more yellow orangey looking. Deneb, Vega, they're bright white. We'll visit a couple of sets of stars, and you'll estimate the angular distance between them or how far apart they seem to be in the sky. And you can use your hands as a measuring stick. You keep your arm outstretched in front of you when you do this, and your pinky covers about a half a degree of sky. That's the size of the full moon. Your fist, 10 degrees. Three fingers, about 5 degrees. And the hook'em horns, 15 degrees. Now, everyone's hands are different. Some are smaller than average, some are larger than average. So you can calibrate your hand measures by using the Big Dipper. And here's the measurements to help you adjust your hand measurements. You'll visit another set of stars and you'll estimate their altitude and azimuth. Altitude is measured in degrees of arc from the horizon, which is 0 degrees, to the zenith, the point directly overhead, which is 90 degrees. Azimuth is measured along the 360-degree horizon, with north being 0, east 90, south 180, and west 270. You'll learn about RA and DEC. The easiest way for me to think about celestial coordinates is to extend the Earth's latitude and longitude lines out into space. Think of a ball inside of a much larger ball, the Earth inside the celestial sphere. The Earth's equator becomes the celestial equator. Earth's north and south poles become the celestial south poles. Earth's latitude lines become these parallels of declination. And they start at the equator and go 90 degrees north to the north celestial pole, which is designated plus 90 degrees. And they go 90 degrees south to the south celestial pole, which is designated minus 90 degrees. when the Earth's longitude lines are projected out to the celestial sphere, they become the celestial right ascension circles, or we call it RA for short. RA is designated in time, hours, minutes, and seconds. There are 24 circles at 1 hour intervals. These hour circles run from the North Pole to the South Pole. The starting point, 0 hours, is at the vernal or the spring equinox. It's the point where the sun crosses the equator on its way from the southern hemisphere to the northern hemisphere. And this happens around March 21st. The starting point is 0 hours, and they run towards the east and go all the way around and come back to your starting point of 0 hours. There is no 24-hour circle. They measure the distance in time of an object on the celestial sphere from the vernal equinox. The vernal equinox is located in Pisces. 1 hour of RA is equal to 15 degrees. So just as you can pinpoint any place on Earth with latitude and longitude address, you can pinpoint any object in the sky using RA and DEC. The star charts will have your right ascension hours at the top and usually also at the bottom, and your uh, declination lines will run along the sides of your star chart. So using this cross reference, you can figure any object in the sky. You will visit variable stars. These are stars that change in brightness. You'll learn how to estimate the brightness of the variable star by using the known brightness of nearby stars as a measuring stick. And the book does contain 8 ABSO star charts for these 4 stars. And you will make 4 magnitudes of 2 of these stars. You will observe the nearest sun to us, the nearest star to us, our own sun. This is extremely dangerous to do. Never look at the sun with your naked eye. You could be blinded instantly. The program asks that you use a pinhole camera to project the sun's image onto a piece of paper and look at it that way. You can use a telescope, but only with the proper filter. Never look at the, never use solar filters designed for the eyepiece. I don't know if they even make those anymore, but if you happen to have one, throw it away. They can crack from the sun's heat and blind you. You'll also look at some meteors. You'll be plotting the path of 2 meteors on a star chart. And this takes a little bit of advanced planning. You need to determine ahead of time what part of the sky you're going to be looking at and have the proper star charts handy. And then when you see a meteor, you know its starting point that you saw it and its ending point, and then mark that on your star chart. Now, all of these exercises are really easy to do, and the observations are all supposed to be done only with your naked eye. No telescope or binoculars needed. So, at this point, you have a choice to make. How will you continue your trip? Will you decide to go with the naked eye deep sky list? It contains the brightest objects. Or, and if you do that, you do have to have a dark sky sight in order to see most of them. Some are bright and easy to see, like the Pleiades or the Beehive or M31. But for most of these objects, the only thing you can expect to see is just a little small dim fuzzy. The telescope deep sky list contains objects that are too dim to see without a telescope. Most of these objects are really easy to find. Most of them are located near bright stars. A few of them will be challenging, but whether you go naked eye or telescope, you look at the same types of objects either way. You'll visit our nearest neighbor in space, the moon. You'll learn a little bit about its phases, and you'll even learn to recognize some of the detail on the moon. You'll venture out a little further into the solar system and visit some of the other planets that share the solar system with us. You choose which 3 of these planets that you want to look at. We'll look at a comet that comes out from the far reaches of the solar system and ventures close enough to the sun that it becomes visible to us. Now, you can use a naked eye comet for either the telescope list or the naked eye list. You'll visit some of the most beautiful double stars in the night sky. Look at the subtle color differences between these 2 stars. This is Alberio. One star is yellow and one star is a pale blue. When you look at stars you want to always look for color. You'll visit open clusters of stars. This is NGC 457. It's one of my favorites. Uh, we think it looks like ET, the extraterrestrial. His eyes are bright, these two stars. Dimmer stars make up his body here. His arms go out to the sides, and his legs run down this way. This is a great object for public outreach. Uh, the kids just really love it. You will look at globular clusters of stars. This is another one of my favorites, NGC 6441. It's very easy to find not far from the Stinger and Scorpius. And it's a beautiful view with 6441 and bright yellow G Scorpii in the same eyepiece field. You look at other galaxies. This is M51. And when you look at this galaxy and its companion 5195, look for this bridge that connects the two galaxies. It's very faint, but I've seen it many, many times. You look at planetary nebula like M57. This is also another object that's great for public outreach. It really does come through light pollution. And it's easy to find. It's located almost dead center between Beta and Gamma Lyrae. The universe sampler is designed to be completed in a year, but you don't have to complete it in a year. Take your time. Learn each lesson. It'll pay off in the long run. Once you've completed this program, you should be well acquainted with the night sky, and you should be able to find your way around among the stars without a problem. You should be in a position to know what type of objects interest you most. Is it galaxies or star clusters or what? And you should be ready to continue observing with another one of the League's programs. Your reward for completing this program is, of course, a certificate and a pen. Now, if you look at both the telescope list and the naked eye list, you do receive 2 certificates, but you will only receive 1 pen, and it is counted as only 1 program. Now, there's nothing magic about becoming a good observer. It takes time. It takes patience, lots of patience. It takes a willingness to put forth the effort. You won't become a good observer if you rush through and look at something real quick and rush off to find the next object. You need to really look at it. And it takes a yearning to see what's in this fascinating universe that we live in. So that's it. Do you have any questions?
Can she hear us?
Yeah, Amelia, you can hear us, right?
Yes.
Yeah.
Okay, great.
You're in 51. What size telescope were you using for that sketch?
And so we got to get our volume up here. Somehow.
Yeah, I missed that.
I'm gonna stop sharing, I guess, so I can come down here. Okay, so your question again?
The sketch you did of M51, what telescope were you using?
I was using a 13-inch,
Okay.
Ultra 13.1.
Okay.
Really close up on it. Yeah.
Hi, Amelia. This is Greg Shadle. And I wondered if do you have a way you figure out what to do tonight? For instance, it looks like it might be a clear sky for a change tonight. And I'm thinking, okay, I need to go out and look at the next thing on the program. But I ended up always having to start at the beginning and read the whole thing to figure out what might be available, what I should be working on this evening. And I wondered if you had a method for that.
I keep a planisphere handy.
Okay.
That, kind of shows you what part of the sky is available. And then you look at your list and see, okay, is this a summer object? Is this a winter object? Is it a spring object? Give you kind of a choice as to, okay, what's going to be up.
Okay. So you kind of have that in your head as to what season things are available. Is that how you do
Yeah.
it? Is it?
Yeah.
Okay.
And as I said, a planisphere, that is a big help.
Okay. I guess if nobody else has another question, I wondered about when you look at transparency.
Uh-huh.
I have cataracts, so I mostly only see 3 stars in the Little Dipper, and that's it.
Okay.
So,
So you have a
is
definite advantage.
is there another method I should be using, or should I just say, hey, that's the way it is?
But that's the way it is.
Okay.
I had gotten almost that bad before I had cataract surgery.
Well, I got to wait another year, so.
Yeah. You just have to live with what you've got.
Okay.
Your seeing and transparency rating, that's going to be individual, or would it be more like what everyone else experiences?
You should learn to estimate the sky yourself. You can ask other people what they think, but you should really try to learn. Okay, tonight is this, it's a 3, or tonight is a 0. you know.
But like, for example, Greg is going to see the sky as a 2, where I may see it as a 5.
Yeah, and you should record it as a 5. Everybody's eyes are different. That's why we have that. It's your personal observations. What does the sky look like to you? Are the stars really bright and steady, or are they just twinkling all over the place?
Amelia,
Uh,
I have a question, and this is actually asked by one of our members, Richard Clements, from chat. He's online, and the question comes up a lot. He's asking if um, when as people complete their observations and the program, do they send all of their observation logs to you, or do they send them to our liaison, which is me? And I sign off on them and then send them to you.
They can do it either way. They can definitely give them to you, and you sign off and just send me an email that so and so has completed the program, and I'll take it from there. Or if they'd prefer, they can send them to me either by mail or PDFs on the computer.
Okay.
Amelia,
Go. One last question. Someone else asked if they could do this program with a Dwarf 3 or one of the new telescopes that the little I guess sea star like telescopes. I'm guessing since it's no aid and no go to that wouldn't work.
Sea Star, no, that would not work.
Okay. Gotcha.
I really don't know what the smallest telescope can be used for this program. Like I said, I did this program in the mid 1990s. So that's been quite a while ago. And the skies at our dark site were much, much darker then than they are now. These days, it's getting very hard to find really dark spots to do observing. So I really don't know how small of a telescope you can do this program with.
I guess, Amelia, this is Kevin Hahn. I'd just like to jump on the whole visual differences of eyesight and so forth. I'm doing the challenge as well. My next one on there that I'm gonna jump on hopefully this weekend is the variable stars. Like,
Uh-huh.
do you have any kind of like a hint or any kind of advice on maybe how you would go about that? That from that perspective of just like everybody's eyesights are a little bit different, and of course, dark sky versus not so dark sky, and
Well, if you're going to use AAVSO star charts to do your variable stars, you have known magnitudes of the stars around your variable stars, so you can calibrate from that. If you don't use you have to have something that shows you the magnitude of the stars around the variable star in order to compare.
So the 4 brightness estimates, I'm assuming you mean on 4 different nights, correct?
It doesn't necessarily have to be, just allow some time between the observations.
I just didn't know if you were
One early in the evening, and you could do one late in the evening if you wanted to.
okay. I didn't know if you were expecting us to do it like at the beginning of its lowest brightness, at the end of its highest brightness. I didn't really understand the expectation. That's why I was asking, like, how far apart should we make those brightness estimates for whichever 2 stars we choose?
Yeah. I don't know, just allow some measurement of time, because most of the variable stars don't change, say, in an hour. It's going to take several hours or several days and sometimes several months or years before they change. But the sky conditions may change from early in the evening to later in the evening. So you may see something as being brighter in one part of the night than in another part of the night just because of the sky conditions.
Okay, that makes sense. Thank you for the clarification on that.
yeah, thank you. That kind of ties into what I was asking. I just didn't do a very good asking.
Amelia, I have a couple questions.
Uh-huh.
The first one's on seeing.
On what?
Seeing, measuring
Oh.
seeing. The Astronomical League often referred to are the planets twinkling, but when you're observing and there are no planets, and then the big stars are always twinkling or something, it gets a little difficult. Do you ever use a different scale, or you still just give it your best on that? What do you?
That's the only scale I've ever used. There's a Bortle scale, which I know nothing about, that a lot of people use, but I've always used this, 1 to 6.
Okay. Yes.
It's just what I'm used to, and I just never changed.
Yes. My second question, at my house, I don't see the Little Dipper, and so I usually try to find a star above me and do the faintest at zenith and mark down a magnitude on that star. Is that okay
Uh-huh.
with this program? Okay.
Okay.
What?
Repeat that.
Yeah.
I just don't see the Little Dipper from my driveway, and so I'm usually just looking up and marking the faintest star I can see above me. Is that for transparency? And I'll mark the magnitude down, so I just sort of keep track of how clear is that sky to me. Is that okay?
Yeah.
Okay.
That's fine.
Yes. Thank you.
It doesn't matter where that star is that you're using as your guidepost.
Okay. Thank you.
Anybody else?
Just someone that they can also email you. They can email you if they have questions.
Oh yes, if you think of questions later on, you can always email me with those questions. I'll be glad to answer them for you.
Well, Matt, do you have anything that you want to add? I just, for myself and everybody else here, I just want to, thank you very much for coming on and doing this for us. We've got a group of 20 some people here.
My pleasure. My pleasure. Thanks for having me.
Thank you, Amelia.
Yeah, thank you
I'll
very
be in
much.
touch.
All right, well, have a great night.
All right, you guys too.
Thank you.